by the substitution rule. I'm your host, Dr. D. Okay, here we go. Today what we're doing is we're learning a technique of performing an integration that you otherwise could not perform. And this technique is called the substitution rule. This is actually the easiest of the integration techniques. Chapter 6, we go through a whole grocery list of lovely integration techniques. But here we are with the substitution rule. Now, we start with u equals g of x. So u is a function of x. So that means du dx, the derivative of u with respect to x, is going to be g prime of x. So another way I could write this same statement is that du equals g prime of x dx. All right, now, if I have the integral of f of g of x times g prime of x. Now notice that's an integral of a product that I have no capability of performing because you can't use the product rule in reverse. So I've got the integral of f of g of x, so you see the function g of x in my integral, times g prime of x, which is the derivative of that function. So when you see that combination, then you can say this equals the integral of f of u du. Because remember, if u is g of x, then f of g of x is f of u. And then we just said that du is g prime of x dx. So there's your g prime of x dx becomes du. So we've got the integral of a function times the derivative of that function, and we get an integral without a product that we can perform. Okay, so today's lesson is just going to be a whole series of example problems, and you're going to get the idea of what this substitution rule is just by seeing it over and over and over again. So let's just get on this. Oh, yeah, here we are. Okay. So first of all, we have the integral of 2x times the square root of 1 plus x squared dx. Now, first thing I do is I'm going to put it in the order so that you can see we have our integral of f of g of x. What's that mean? Well, the g of x is the 1 plus x squared. And notice g prime of x is 2x, the derivative of what's under this radical. Now, I can't just distribute the 2x into a radical. That's impossible. So what I do, though, is I say let the u equal 1 plus x squared. And that means du is going to be the derivative of this, which is 2x dx. And so now our new integral becomes the integral of the square root of u. The 2x dx becomes du. So now this is an easy integral. I can do this because the integral of the square root of u du, same thing as the integral of the square root of x dx. So what I do is I just make the square root the 1/2 power. When I perform the integration, the power goes up to 3/2. I divide by 3/2, I'm adding c. Now dividing by 3/2, same thing as multiplying by 2/3. And so I have 2/3 u to 3/2 plus c. Now, u isn't the original function we were given. We were given a function of x. So we need to put the x's back in, and we know that u equals 1 plus x squared, so we just substitute the x's back in, and there's our final answer. That's it. Game over. So notice we were able to do an integration here that without the substitution rule we couldn't have done. Okay, like I said, you just need to see more and more and more, and pretty soon this will become easy. All right, so integral of x cubed times cosine of x to the fourth plus 2 dx. Now, same thing. I can't distribute my x cubed. But notice the derivative of the inside of the cosine function is 4x cubed, and I have an x cubed outside. So what I'm going to do is I'm going to go, let's see, now, this is a mathematical term. I'm introducing a new variable, so I'm saying let this new variable equal whatever I want it to equal. So I'm saying let u equal x to the fourth plus 2. Now, since we've defined u to be x to the fourth plus 2, now we can operate on it. So if u equals x to the fourth plus 2, then that tells us that du equals 4x cubed dx. Now, I need something to substitute in for dx. I don't want du, I'm looking for dx. Well, actually, I'm looking for x cubed dx. So what does x cubed dx equal? Well, x cubed dx equals, get rid of this 4, and it equals du over 4. So x cubed dx equals 1/4 du. All right, so now I can rewrite my integral as the integral of, now I've got the cosine of u, because u is x to the fourth plus 2. Now notice the x cubed dx becomes 1/4 du. Now, clearly I can bring the 1/4 out in front because it's just a multiplier. So I've got the integral of cosine u du. Now, what's the integral of cosine? It's sine. Plus c, senor. Okay, now, we can't leave the u in here because we were given x's. So we need to put our x's back as our final step. So it becomes 1/4 sine x to the fourth plus 2 plus c. That's it, game over. All right, let's do another one. Okay, this time, notice what's the derivative of the inside of this thing? It's 2. So basically I have the situation, I can say let 2x plus 1, oops, rats. You know what, we'll just do this. Let 2x plus 1 equal u. And so then, that means du equals 2 dx. The derivative of 2x plus 1 is just going to be 2. So du equals 2 dx. Now, remember, I don't want du, I want what dx equals, because I need to substitute that. So, I'm going to say dx equals 1/2 du. All right, now I'm ready for the integration. So, notice I have the dx is a 1/2 du. So I'm going to take the 1/2 out in front right away this time, because I know better. And now the square root of 2x plus 1 becomes the square root of u. And then I've got my du. So this equals 1/2 times integral of u to the 1/2 du, which equals 1/2 times u to the 3/2 over 3/2 plus c, of course. Now, we flip the 2/3, and it makes it 1/3 u to 3/2 plus c. Because half of 2/3 is 1/3. And our final step is to put our x's back. oops, to the 3/2 power. We'll edit that out. That's it, game over. Piece of cake. Starting to get easy now, right? Yes, of course it is.
That's the smartest thing I've ever heard anyone say about anything.
Okay. Now, this time, you look inside the radical and you see 1 minus 4x squared. Think about taking the derivative of this. It's going to become negative 8x dx. Well, there's your x dx. Bam! So once again, we just say let u equal 1 minus 4x squared. And that means du equals negative 8x dx. Remember, I'm looking for what x dx equals, because that's what I'm trying to substitute for, x dx. So that means x dx equals negative 1/8 du. All right, now I'm ready to cook. So I take my negative 1/8 outside the integral, and I've got my x dx on top that I'm just going to turn into a du. And what's on the bottom? The square root of u. That's it. Now, it's a really simple integration. I've got negative 1/8. Let's just make this u to the negative 1/2 du. And so that gives us negative 1/8. Now, doing this integration gives us u to the 1/2 over 1/2. Plus c, senior. Okay, and then reciprocate the 1/2 and you get negative 1/8 times 2 is negative 1/4. U to the 1/2 plus c. And, you know what, let's just, instead of making this u to the 1/2, let's make it square root of u plus c. And then the last step, of course, is to put the x's back in. So this becomes, let's just make it negative radical 1 minus 4x squared all over 4 plus c. Bam! That's it. Now, this next example, we've got e to the 5x. Now, we know the integral of e to the x is e to the x. But e to the 5x, we need substitution. So, notice what we're going to say is, let u equal 5x. That means du equals 5 dx. Now, I'm looking for a substitution for dx, so dx is going to equal 1/5 du. All right, now I'm ready to substitute. So this becomes the integral, well, 1/5 integral of e to the u du. Okay, so now I have the integral of e to the u is e to the u. So this just becomes 1/5 e to the u plus c. And then all we have to do is plug in our x's back in for u. So this becomes 1/5 e to the 5x plus c. Now, take a look at this. If I were to take the derivative of 1/5 e to the 5x plus c, then I say the let's just do it like this. D dx of 1/5 e to the 5x plus c equals. Now, the derivative, well, you know what, we can take the 1/5 out in front. So, now let's not do that. Let's just do the derivative. So, the derivative of e to the 5x is e to the 5x, and then don't forget the chain rule. Okay, derivative of e to the 5x is e to the 5x times 5. And derivative of c is 0. And notice what we have. 1/5 times 5 is 1, so this just becomes e to the 5x. So notice what I did. I just showed that the integral of e to the 5x is 1/5 e to the 5x plus c. Now when I take the derivative of 1/5 e to the 5x plus c, I get back to what I had originally. Okay, now, later on, as you get comfortable with this, you'll be able to do this in your head without even going through this whole substitution. So, in past years, we've always referred to it as the reverse chain rule. See, if I'm taking the integral of e to the 5x, I get e to the 5x, but then I have to multiply by 1/5 to counteract the chain rule. So, because I know when I take the derivative of e to the 5x, I'm going to get e to the 5x times 5. When I take the integral of e to the 5x, I'm going to end up with e to the 5x times 1/5. And, clearly, we will never forget the plus c. Okay, that's it. Let's cruise onward. I have a little more juice here. Okay, notice what's inside 1 plus x squared. The derivative of that is just going to be 2x. And I don't have a 2x here. So what I'm going to do is I'm going to say let u equal 1 plus x squared. And then du equals 2x dx. Okay, 2x dx, the one derivative of 1 is 0. Okay, now du is 2x dx, but I don't have just an x dx, I have an x to the 5th dx. So what I say then is if let's see what. Oh yeah, here's what we do. This is a little trickery here. So if u is 1 plus x squared, then that means x squared equals u minus 1. Okay, just subtract 1 from both sides. Now, I'm going to say then x to the 4th equals u minus 1 quantity squared. Okay, so now what I end up with is this thing becomes my well, let's do one more thing. I've got du is 2x dx, and that means the x dx equals 2 du. All right, so what I have is the integral of the square root of u times x to the 5th, which is going to be x to the 4th times x dx. Okay, let's look at it again real quick. So we've got square root of 1 plus x squared, which is square root of u. Now, the x to the fifth is x to the fourth times x dx, which is 2 du. So now, here's what I end up with. So I'm going to take my 2 outside here. Now, what I do is I distribute this binomial here, and I end up with the square root of u times u squared minus 2u plus 1 du, which equals 2 integral of, now let's just distribute the square root of u. So this is really a u to the 1/2. So 1/2 plus 2 is 5/2. Come. Okay, back to the range. U to the 5/2. Now, square root of u times u, that's going to be 1/2 plus 1, which is 3/2. And then the square root of u times 1 is just u to the 1/2 du. And I guess I didn't need that parenthesis. Okay. Now we're ready to integrate. So u to the 5/2 becomes u to the 7/2 over 7/2. So 2 u to the 7/2 over 7/2 minus minus 4 u to the 5/2 over 5/2 plus 2 u to the 3/2 over 3/2. Okay, so this equals 2 times 2/7 is going to be 4/7 u to the 7/2 minus 4 times 2/5 is going to be 8/5 u to the 5/2, and 2 times 2/3 is going to be 4/3 u to the 3/2. Oh my gosh! Plus c. Okay, now last step, we toss in the 1 plus x squared, so we end up with 4/7 times 1 plus x squared to the 7/2 minus 8/5 times 1 plus x squared to the 5/2 plus 4/3 times 1 plus x squared to the 3/2 plus C, senor. That's it, game over. Let's make sure that worked out, just in case I didn't, just in case I may have screwed something up in the process. Let's see. Yeah, something has gone awry. What the heck went wrong here? Yeah, everything's good down to here. Now let's see, when I did the integration, I have, oh, that just burns. Okay, it's not good down to there. Notice, if du is 2x dx, then x dx is 1/2 du. I just knew something felt wrong. Okay, so that means this is a 1/2 outside here. Okay, now, when I distribute the 1/2, okay, it's going to be, let's just get rid of all this junk. Okay, so I've got the 1/2 in front of the whole thing. When I integrate this as 7/2 over 7/2, so we'll just make this a 1/2 here. And now 1/2 times 2 is just a 1 there, and 1/2 times this one. Now, when I flip the 7/2, I get 2 7ths. Half of 2 7ths is 1/7. And then 2 5ths. And then half of 2/3 is 1/3. And so my final answer is going to be 1/7 times 1 plus x squared to the 7/2 plus minus 2 5ths times 1 plus x squared to the 5/2 plus 1/3. Okay, so that's much better. Let's just make sure that one's right too. Okay, so the key thing here is to say the u is 1 plus x squared, that makes du 2x dx, and that makes x dx 1/2 du. And so then the only other trick we had to pull was x squared is u minus 1, and so that means the x to the 4th is u minus 1 quantity squared, and so then we substitute in, we've got the radical with u underneath it, and then we've got our x to the 4th right here, and then we have an x dx right there, 1/2 du is the x dx, and then we go to town. Okay. All right, now, the integral of tangent x dx. Until now, you haven't been able to do this. But with the substitution rule, we can now do it. What we do need to do, though, is we need to look at tangent x as sine over cosine. Now, notice I have a sine x dx on top. So if I let u equal cosine x, the period isn't over yet. Don't worry about that. Okay, so u is cosine x. So that means du is going to equal negative sine x dx. The derivative of cosine is negative sine. Now, remember, we want what sine x dx equals. So that means sine x dx equals negative du. All right, so that makes our integral then negative. Now notice the sine x dx is my du, and the cosine x is my u. So basically this equals negative integral of 1 over u du. Now, remember, the integral of 1 over u is not u to the 0 over 0. It is natural log u. So we have negative natural log u, plus c, of course. Okay, now, what's u? It's cosine x. So this equals negative natural log, oh, and I'm sorry, have to have absolute values around the u, because natural log can never be negative. So negative natural log of the absolute value of cosine x plus c. Now, one more thing, we have the property of logarithm says we can take this negative and make it the exponent. Well, cosine x to the negative 1, that's 1 over cosine, which is secant. So that means our final answer equals natural log, absolute value of secant x plus c. Do you think you should possibly memorize that? Yes, I'd say so. Okay, so really pretty simple substitution that we just saw that we've got sine x dx here, and the derivative of cosine is sine x dx, or negative sine x dx. So we end up with the substitution. We can do our integration then with the u, and then we put the cosine back in, or the x's back in the u. And then, last step, clean up the negative in front of the natural log. Bam! Integral of tangent is natural log secant. Piece of cake. Okay, now, here we are with a definite integral. So this can be just slightly different, but there's just one little tripping hazard here that I want to make sure you guys don't mess up. Okay, obviously what's underneath the radical, 2x plus 1, the derivative of that is just going to be 2. So I know I can use my substitution, or like we said before, inverse chain rule. But what we're going to do is we're going to say let u equal 2x plus 1. And that means du equals 2 dx. And that means dx is what we're trying to substitute, rats, dx, which is what we're trying to substitute for, is going to equal 1/2 du. Don't make that mistake and say it's 2 du, or else it could be a pain. Okay, now, we're not ready to substitute because we haven't substituted for the limits of integration here. See, this is not a u anymore. You can't just say it's the integral from 0 to 4 of 1/2 square root of u du, because the 0 and the 4 are not u's, they're x's. This is when x equals 0. What's u going to equal? Well, if x is 0, then u is going to equal 2 times 0 plus 1. So u equals 1. And when x is 4, what's u going to equal? 2 times 4 plus 1. That's 9. So now we can substitute. You do not want to ever mix x's and u's. Never. If you make that statement one single time, then hackage will ensue. Hackage will ensue? Yes, don't let that happen to you. Okay, so our new integral is going to be 1/2 the integral from, instead of 0 to 4, it's from 1 to 9 of the square root of u du. Now, the cool thing about this, we never have to go back to x's. Watch the magic. So we've got 1/2 integral from 1 to 9 of u to the 1/2 du, which equals, now 1/2 times u to the 3/2 over 3/2. And you don't go plus e, you just go from 1 to 9. And so this is going to equal, flip the 2/3, so 1/2 times 2/3 is 1/3 u to 3/2 from 1 to 9. All right, now what is 9 to the 3/2? It's the square root of 9, which is 3 cubed. So this becomes 1/3 times 27 minus 1 to the 3/2, which is 1. So this is going to equal 26 thirds. That's it. We never have to go back to the x's because we solve the integration with u's because it's a definite integral. So, number one, do not ever even write this statement. If you have, let's just do it like this. If you have the integral from 0 to 4 of, well, we can put the 1/2 out here, of the square root of u du. Don't even have that on the paper because you cannot mix x's and u's. So you always change your limits of integration and change your integration and then just perform the integration. Now some people think, well, I'll just leave everything in x's, like I'll put this back when I do the integration, I'll put x's back in here and then integrate, then put a 4 and a 0 back in there. No, do not do that. Number one, it's formally incorrect. But number two, it's way easier to screw something up that way. So keep it all x's, all u's. Okay. Same situation here. We've got a definite integral and we need to do a u substitution. So we say let u equal 3 minus 5x. So that means du equals negative 5x, negative 5 dx. And that means that dx equals negative 1/5 du. Now, if u is 3 minus 5x, we need to know what u is when x is 1. So, when x equals 1, u is going to equal 3 minus 5, which is negative 2. And when u equals 2, when x equals 2, then u equals 3 minus 10, which is negative 7. So now and now only we're ready to make our substitution. So we say this is negative 1/5 times the integral from negative 2 to negative 7. Oops, rats. Oh, that just burns. Of, now the dx is a du, and the 3 minus 5x quantity squared becomes a u squared. So once again, we have an integral that we can perform. Now, there's one slight problem here. We always want the integral to go from smallest to greatest. Well, -2 is greater than -7. So we're going to flip the limits of integration. When you flip the limits of integration, you merely change the sign outside. So this whole thing becomes positive 1/2 integral from -7 to -2. So remember, we're going from left to right of u to the -2 du. All right, so raise the integral, or the power by 1, and that makes u to the -1 over -1. So this becomes -1/2 u to the -1 from -7 to -2. So this equals, yeah, let's just do it like this. So it's going to be -1/2 times the quantity. Now I put in my -2 first, so it's 1 over -2 minus, put in my -7, so 1 over -7. All right, so let's not get confused by the signs. If we distribute this, then we have 1/2 times 1/2 is 1/4, and that's positive. And then this minus a negative becomes positive, so this is going to end up being minus 1/2 times 1/7, which is going to be 1/14. So let's see, let's just make our common denominator, let's see, 4 times 7 is 28, yeah, so it's going to be 4 28s, right, 4 28s minus 2 28s. Did I do that right? Oops, no, I didn't. That algebra 1 stuff's pretty tough. All right, how about 7 28s minus 2 28s, and that equals 5 28s. That's it, game over. Let's just make sure I didn't screw something up on that either. What the heck? Oh, man. Why didn't you guys point that out? Okay. This is -150. Why did I put a -1/2 out there? Ugh, this is getting annoying. All right. Let's just get rid of the whole thing. Oh, man. Okay, so -1/5 is what goes outside my integral. So that makes this a -1/5 here, and this is a -1/5 there. All right, so now I'm going to go -1/5 times the quantity. So u to the -1, I'm putting my -2 in there, so it's 1 over -2 minus 1 over -7. All right, so this is going to be 1/10 minus 1 over 35. All right, and this equals let's see, 2, 5, 70. Okay, so this makes 7/70 minus 2/70, which equals 5/70. And 5/70 equals 1/14. Okay, that's it. Man, that was excruciating. Hopefully you guys did it on your own and you didn't fall into my trap, but that's how you actually do this. Okay, last idea. Oh no, there's one other. Okay, integral from 1 to e of natural log x over x. Now, what we see here is the derivative of natural log x is 1 over x. So what we're going to do is we're going to say let u